Motor drivers are essential components in robotics and mechatronics projects. In this video, we'll explore motor drivers in detail. We'll specifically discuss the following motor drivers: L293D, L298N, TB6612FNG VNH2SP30. Since this is an in-depth video, it may take a bit of time, so stay tuned. Welcome to Polonium Technologies. What is a motor driver? As the name suggests, a motor driver is responsible for running motors. It works like an amplifier, converting a low-current control signal into a higher current output that can actually power a motor. Why is this necessary? For example, a 12-volt motor may draw 1 amp of current. A microcontroller like an Arduino Uno can only provide 5 volts at about 20 milliamps, and a Raspberry Pi or Node MCU outputs just 3.3 volts. If you connect the motor directly, you won't run properly, and you might even damage the controller. That's where a motor driver comes in. Positioned between the motor and the controller, it takes power from an external supply while receiving control signals from the microcontroller. The driver then amplifies these signals and provides the motor with the voltage and current it needs to run at full capacity. How a motor driver works. Most motor drivers are built around an H-bridge circuit. The H-bridge has 4 switches: S1, S2, S3, and S4. By opening and closing these switches in specific pairs, current flows through the motor in different directions. S1 and S3 on, current flows from A to B, motor rotates clockwise. S2 and S4 on, current flows from B to A, motor rotates counterclockwise. All off, the motor stops. All on creates a short circuit, risking damage. In practice, physical switches are replaced by transistors or MOSFETs. Transistor-based drivers are simple but less efficient, while MOSFET-based drivers are widely used today for their efficiency and reduced heat generation. Popular motor drivers. Now let's start with the L293D. This is a dual-channel transistor driver. Operates from 4.5 volts to 36 volts. Continuous current 600 milliamps. Peak current 1.2 amps. Supports PWM for speed control. Commonly available as modules and Arduino shields. Next, we have the L298N, a dual H-bridge transistor driver. Supports up to 46 volts, 2 amps per channel, 3 amps peak. Includes current sensing and a heatsink. Affordable and widely used in robotics. Moving on to the TB6612FNG, a MOSFET-based dual-channel driver. Operates from 2.5 volts to 15 volts, 4.5 to 15 volts recommended. 1.2 amps continuous per channel, 3 amps peak. High efficiency, low heat, and supports PWM up to 100 kHz. Includes standby mode and reverse battery protection. Finally, let's look at the VNH2SP30, a high-power MOSFET-based driver. Operates at 12 volts to 16 volts. Handles 14 amps continuous, 30 amps peak. Highly efficient, includes current sensing and thermal shutdown. Expensive, but ideal for automotive and heavy-duty robotics. Transistor versus MOSFET drivers. Transistor drivers are larger, less efficient, 40 to 70%, and produce more heat, but cheaper. Great for small DIY projects. MOSFET drivers are compact, highly efficient, 91 to 95%, minimal heat, ideal for battery-powered and professional applications. Choosing the right motor driver. When selecting a motor driver, consider motor voltage, match the driver to the motor's rated voltage. Motor current, ensure the driver can handle the motor's stall current. Application. DIY projects may use transistor drivers. Serious projects benefit from MOSFET drivers. Power source. For battery-powered projects, MOSFET drivers are preferred due to efficiency. We've also included a comparison chart of all the drivers discussed for quick reference. Some lesser-known drivers also exist that, while less popular, are highly durable and efficient, perfect for industrial and heavy mechatronics applications. That concludes this video. We hope you learned something new about motor drivers today. If you found this helpful, please hit the like button, share it with your friends, and don't forget to subscribe to Polonium Technologies for more electronics and robotics content.